Hello everyone, this video is on the topic algebraic expression and identities, which we have started, and we are going to see some good questions by the help of our workbook, where today we are going to start with worksheet 1, question number 1. Question number 1 says that separate the constant and variable from the following expressions. So in class we have discussed, although I will reiterate that constants and variable, these are the pillars of algebra, where constant, the word itself means the value, the thing whose value is fixed, wherein we see that numbers come into the role play. So 1, 5, 4, these are called as constants. Variable is on the other hand is a thing whose value is not fixed, missing, we have to find out, or like that, and whose value can change according to the situation. So in order to represent them, we use letters, alphabets like A, B, C, X, Y, Z, or even we can use Greek letters. We can see Greek letters, alpha, beta, gamma, as Greek civilization had a good contribution in the world of mathematics, and even Indian history is also very rich in mathematics. So I would like to say that even variables can be in the form of k, kh, g, and so on, because only a symbol is required to represent them. Okay, fine. So let's see what the question is. We have to separate the constant and variable, right? So the first part says 8 plus x, right? So wherein we can do what? That 8 is obviously the constant and x is rather representing the variable, right? Likewise, if we see the second part, so likewise you can also write in your notebooks. If we see the next part, then it says 9x plus yz. So 9 9x is one term, whereas yz is the second term, because we discussed that the term changes when plus or minus sign is in the situation. On multiplication and division, we do not say that the term is getting separated. So there is one plus sign over here involved in the question. So before plus sign, we can see 9x, and after plus sign we have a term yz. So it's a two term, it's an algebraic expression having two term. Now in 9x, if we see the constant part, I will write over here 9x. If we see the constant part, so which is that 9, and the variable part is x, whereas in the other term yz, the coefficient, as we can see, no number is here visible, But although if no number is there, we can take the coefficient, numerical coefficient, as 1, because even if we multiply 1 to yz, it will remain yz only. So the constant is 1 and the variable is yz itself. So in the name of constant, we can give 9 and 1, and in the name of variable, we can say x and yz, or even we can separate the y and z also, that y is 1 and z is another third. So in this way, hopefully you will be able to do the other parts. If you face any doubt, then you know what to do. Proceeding to the next question, that is question number 2. Question number 2 says that question number 2 says that write the type of following algebraic expressions: monomials, binomials, trinomials, polynomials. So wherein we know that if there is one term, then we name it as monomial, wherein two terms we call it binomial. Again, we have discussed all these in the class as well, is the offline class as well. And when there are three terms, we call it trinomial. When there are four or more terms, 5, 6, 7, then in that case, I prefer to go by the word multinomial, just to avoid the confusion that many times I find that whenever I ask, students are having this misconception that if there are more than three terms, then they are called as polynomial. But it is not like that, and in class we have discussed that what exactly the definition of polynomial is. So multinomial, or currently from class 8 point of view, you can use the word polynomial. And although there is a logic behind this, that polynomials in general are all these expressions. Even monomial is a type of polynomial, binomial, trinomial, all these are polynomials, but they are having a specific name on a particular condition, so we will use them, wherein for the four or more term cases we can go with the word polynomial. Fine. So let us see 9 minus 3x. So wherein 9 is one term, 3x is another term. So how many terms do we have? 2. So what name it should get? Binomial. Likewise, if we see the next part B, 3y square is one term, then minus, so term will change, 5y is the second term, and 8 is the third term. So what we can say, that it is having three terms, so its name should be trinomial. Likewise, part C is also having three terms. Part 4D is having 1, 2, 3, 4 terms. So for this, we are not having a particular name, so we can go with the word polynomial itself. And 9x, 3x square, 15x cube minus 7. So next part is also having 4 terms, so it will be also called as polynomial. But again, don't make any misconception that if 4 terms are there, we call it as polynomial. That is a special name, nothing like that. So be clear with concepts. Let's go to the next question, question number 3. Question number 3 says, write the degree of each polynomial. Yes, here you will find this class beneficial because we didn't got enough time. Today's class, at least, maybe in tomorrow offline class, brick mortar class, we'll be able to discuss further about these things. So degree. So what do we know about the degree of polynomial? Let me give the information which I have with you. Let me share it. So degree, we find the definition going in this manner, that the highest power of the variable in a polynomial is called degree. यानी कि आसान शुद्ध सरल भाषा में, हिंदी भाषा में बोले तो सबसे ज्यादा जो पावर जाते हुए हमें दिखाई दे वो उस पॉलिनोमियल की डिग्री हो जाती है। पर फिर यहाँ पे एक बात आती है, अगर हम क्वेश्चंस पे ध्यान दें, सब पार्ट्स पे ध्यान दें कि कहीं पे एक वेरिएबल है, कहीं पे दो वेरिएबल एक साथ हैं, तो ऐसे में क्या करना होगा। So I was saying that yes, as we can see in our question, do we have the option of zoom in? Although, so xy plus 7z. So the first term xy, if there would have been single terms, we would have checked its power and then comparing the highest power. Like if you see the part B, that is a good example to start with. So 3x square minus 5x cube plus 9. So if you observe 3x square, the power of x is 2. If you observe the second term, the power of x is 3. And if you observe the last term, the power of x is 0. Variable is not there, it means power 0. So comparing the highest power out of the 3 term of x is 3, correct. So its degree will be 3. And that becomes your answer. But when we come to the first part where it is xy plus 7z, then there is a twist. And we need to be attentive to it, which says that x, y. So two variables are there. So the concept says that you check the power of all the variables which are there in a single term. So x is having power 1 and writing directly plus would not be correct. And y is having power as well 1 as well. So in such a scenario where combination of variables is there, then we need to we need to sum up the powers. So in order to define its degree, the power of x is 1, the power of y is 1. So in all, first term is having collectively the power as 2. Again repeating, xy is combination of x and y. As they are in multiply, they will be called as single term, single group, single team. So each member, if we check x, and we have to, that is the concept goes in this manner. So x power is having 1, so that's why 1 is not written, so it is simply x. And then y is also having power 1. Then we will take out these powers and we will sum up. So 1 plus 1, then we get 2. So the power of collectively xy is 2. Likewise, if we check the power of second term 7z, so 7 is constant, no need to worry for that. If we check the variable z, so z is having what power? 1. Now if we compare collectively as a term, so this xy is having power 2 and 7z is having power 1. So out of the two, which one is highest? 2, obviously. So in that way, we decide the degree of this polynomial as 2. So that will be the correct answer for part A. Please be attentive and do not go for the mistakes. Check for your mistakes. Likewise, if we see part C, so what should be done in the scenario? Let me make space by deleting some things. Hopefully you're writing these things in between, or you can pause. That is the benefit of record lectures. So first term is x power 5, y power 7. So if we add the powers of the first term, 5 plus 7 scenario is there. Likewise, if we see the second term, x is having power 3 and y is having power 8. So 3 plus 8 situation is there. And in the last term, x power 4, y power 4 and z power 4 as well. So now if we sum up, 7 plus 5 is 12, 3 plus 8 is 11, and 4 plus 4 plus 4 is again 12. Oh. So again there is a dilemma. first term is also having power 12 and the last term is also having power 12. Now there is no competition. So the highest power, both are having 12. So simple it is. We should go for the number 12. So the degree of this expression is 12. I hope it is getting clear. So question number 3 is done. Let's see question number 4. Question number 4 talks about in 5 by 7 x y square z cube, write the coefficient of. So again a good question. Coefficient of 5 when it is asking, so you have to skip the number 5 out of the entire term, and whatever is left is its coefficient. So if 5 we ignore, then we have 1 upon 7 x y square z cube. Likewise in the part B, the number is changed to 5 by 7, so you have to skip the number 5 by 7 from our entire term. Then you will be left with x y square z cube. X y square z cube. So this will become the coefficient. Now in part C it becomes 5x. So ignoring 5x from the term or removing it from the term, whichever you feel comfortable. So we have in the variable part y square and z cube with us, and the number 7 as well in the divide. So y square z cube upon 7. So hopefully you are getting it, how to reach to the coefficients. Skipping that part and whatever left is the coefficient. In CBSE it is simply coefficient, although in ICSE we teach it like numerical coefficient, literal coefficient. So numerical we have numbers as coefficient, then literal coefficient only variables are acting as coefficient. In all, if it is asking for coefficient of any particular term and mentioning something, so ignoring that part, whatever is associated with it, that becomes a coefficient, that acts the role of, that does the role of coefficient. Coefficient question number 5, it says separate the like terms in each polynomial. Hopefully you are clear with like terms, same variable as well as having same power. So if we take the first term, which is 3xy, then we need to ignore the constant. There's no role play of constant. If we check the variable, we are having xy, and if we check the other terms, then we have to look for which term is having xy, 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 xy. Did you got any? Yes, I got it in between. It is minus of 8yx. Now some of you might say that this is yx and this is xy, how can they be same? But they are same, because 3xy means 3 into x into y, and minus 8yx means minus 8 into y into x. So finally we have to check for the variables. We are having xy and yx. By which property? Commutative property. X into y, y into x will give you the same thing. 2 into 3, 3 into 2 will give you the same thing, that is 6. So in that way, justified. Now if we see the second term, so we are having minus of 4yx square. So we need to look for the variable part yx square. Do we have yx square, y square? No. X square, y, yes. Yx, no square, no. Minus 3.2 y square x, no, we need x square, not y square, and x square y, one more in the last. So all these three which are having right tick over them, they are like terms. So that was about like terms.